Good evening, ladies and gentlemen. Let's talk about some isosceles triangles. Let's have a formal discussion about isosceles triangles. So let's consider triangle ABC, where AC is congruent to BC. The diagram shows this given fact. AC is indeed congruent to BC by the congruent dashes. What do we know about this isosceles triangle? Well, what we know right now is that the measure of angle A is congruent to the measure of angle B. That is a major property of isosceles triangle. That is the property of isosceles triangle. You have these base angles are congruent. Let's star that. That's a very important property about isosceles triangles. By definition, an isosceles triangle is a triangle that has at least two sides congruent. The base angles are the angles opposite the congruent side. So this is a base angle and this is a base angle because those angles are opposite the congruent sides. So in the last week or so, we've also talked about some other properties of the isosceles triangle, such that if I talk about this guy right here, this median, if I slide that median in there, where CD is a median, what do I know? Well, by definition, a median is a segment that reaches from a vertex to the midpoint of the opposite side. That's a definition. We'll talk more about that definition later. And now I can label these triangles or those congruent segments. And I have that AD is congruent to DB, AD congruent to DB, D is a midpoint. That's given from the fact that CD is a median. What else is CD? Well, from some prior discussions, CD is also an angle bisector. How could we prove that? We could easily prove that by looking at triangle ADC and triangle BDC. They're congruent triangles by side, side, side. Therefore, these corresponding angles are congruent. Therefore, CD is an angle bisector where ACD is congruent to angle BCD. And we talked about a little bit earlier that CD is also a perpendicular bisector. Why is it a perpendicular bisector? Because AD is congruent to DB. Angle ADC is congruent to angle BDC. And since this is true, it follows that the measure of ADC is 90 degrees. And we had a little mini proof of that the other day. So I have CD as a median, CD is an angle bisector, CD is a perpendicular bisector. And because of this fact right here, CD is also an altitude. So those are four nice properties. Let me see if I can zoom out here and we look at all of it. Yes, we can. So if I have an isosceles triangle, as I do, and I consider the median, CD, CD is also an angle bisector, a perpendicular bisector, and an altitude. Good information. So let's do some problems about an isosceles triangle, or at least get started on some problems. Let's zoom back out. We can get a better picture of what's going on and go to the next page. Here I have an isosceles triangle, certainly given in the diagram that AC is congruent to CB. I have AC is congruent to BC, given from the congruent dashes. And I have that the measure of angle A is 6x. So this angle is 6x. This angle, measure of angle B, is 4x plus 14. And the question asked me to solve for x and solve for y. Keep in mind, if we write an equation as we have here, we need to have a reason, a geometric reason, why I can write that statement. And I believe it's easy to see that this statement, 6x is equal to 4x plus 14, because base angles of an isosceles triangle are congruent. And I think I forgot my C in there. I did. Base angles of an isosceles triangle are congruent. Do a little bit of easy algebra, get x is equal to 7. And if x is 7, I have the measure of angle A, which was 6x, is 6 times 7 equals 42. Therefore, the measure of angle B is 42. And I have this statement here. The measure of angle C, this guy here, if these, what did I just find out? I just found out that these angles were both 42 because I found the value of x. 6 times 7 is 42. What can I say about C, and why can I say that? Well, the measure of angle C is 180 minus 2 times 42. And why is that true? That is true because of the triangle sum theorem. Do a little bit of algebra. Do a little bit of arithmetic here. Measure of angle C is 96. It was given in the problem that the measure of angle C was 2y plus 34. Set that equal to 96. Do some algebra. Y is equal to 31. Let's look at another problem. This time I'm just going to get you started, and I will let you finish it on your own. Here I have an interesting diagram. I have two isosceles triangles. The first isosceles triangle I have is I have triangle A, B, C is isosceles. Make sure I spell isosceles correct this time. What do I know about this? I know that AC is congruent to BC. I also know that the measure of angle A is congruent to the measure of angle B. But, can I call this angle A? Well, I really can't call it angle A because if you notice, there's some ambiguity of what this angle A is. So I'm going to have to be more precise. So what do I know? I know that angle CAB is congruent to angle CBA. This angle is congruent to this angle right there. And I'm going to use that information because, again, this problem is going to ask me to solve for x and y. So let's make some statements. I'm going to let you fill in the blank. 2x plus 11 plus what plus x minus 2 is equal to 180. I have given you the geometric reason why I can write that statement, because of the triangle sum theorem, because isosceles base angles are congruent. I will let you fill in the blank, do some algebra, and tell me what x is. I also know that 180 is equal to 142 plus y plus y. That's because of the triangle sum theorem, and base angles of isosceles triangles are congruent. Let's put that congruent symbol there so we know what we're talking about. And where did I get this equation? I'm going to let you solve that equation. Where did I get that equation? I looked at triangle ADB. And what do I know? I know that triangle ADB is also isosceles because of these congruent marks. I will let you do the algebra. Fill in the blanks, give some algebra, solve for x, and solve for y. One more problem that I would like to look at before we close this short video out. Oh, here's a tough one. Oh, I got a lot of triangles going on there. This is what's given in the diagram, or what's given in the problem. The measure of angle 1 is congruent to the measure of angle 2, and FD is congruent. Segment FD is congruent to segment GE. So let's label our diagram, if you will, please. I know these are congruent. These corresponding sides are congruent. And I know these angles are congruent 1 and 2. What my claim is in this problem is that angle HDE is congruent to angle HED. Is this true? That's my claim. Well, I have outlined a proof for you. It is indeed true. And this is going to be a fill-in-the-blank proof. I'm going to start with the given statement. The given statements, FD is congruent to GE, and the measure of angle 1 is congruent to the measure of angle 2. What I'm going to do is look at a couple triangles. I'm going to look at triangle FDH and triangle GEH. I'm going to look at those rascals, and I'm going to prove those things are congruent. And look, I have given you the reason of vertical angles. You're going to fill in the blank of what angles are vertical. And then I'm going to prove through one of the 4 congruent statements that I've used that triangle FDH is congruent to GEH. And I'm going to look at those 2 triangles. Keep in mind, these are the triangles I'm looking at. I'm looking at FDH. Let's use yellow. Let's get that rascal out of there. That was too bold. Looking at FDH, that triangle, and GEH. Color is really nice. Those are the 2 triangles. What do I have? I have these segments congruent. I have angle 1 congruent to angle 2. And I'm using vertical angles to make one more statement. Then I'm going to make that statement that FDH triangle is congruent to triangle GEH. Then I'm going to pull a congruent statement from this particular statement. Again, I'm going to let you fill in the blanks. I'm going to pull a congruent statement out from this statement about congruent triangles. And then I'm going to say, oh, triangle DHE is isosceles. And that's going to tell me that HDE is congruent to HED as desired. So it's your job to fill in the blanks to finish this proof by filling in blank number 1, 2, 3, and 4, and give me a final statement right there. Let's zoom out and look at this entire problem. I think 150 will be a good percentage to look at it. This is one of the homework problems that you had to do. And I will bid you farewell and wish you good luck. See you later.